Java I/O. I/O stands for input and output. And what we're going to do now is talk a little bit about working with mechanisms provided in Java to allow me to input information and data into my applications and then stream or output data back to another source like a hard drive or a network card or something like that. Now, in order to really understand I/O, we have to understand streams, and I'm going to give you a nice little introduction to those streams. Then what we're going to do are talk about the main classes involved in Java I/O. Then I'm going to do a little fundamental input with you and output. Basically, how we can use a console level application to go ahead and receive input and then generate output. Then once we kind of have the fundamentals down, a good set of the basics, then I'm going to review with you a notepad kind of text editor application that I wrote totally in Java that allows me to create a file and save a file as a text file and then open that file back up for editing. The core, the crux of what you have to understand in order to work with I/O in Java are streams. And streams are very clever. Sun was very clever when they came up with how they do input and output. Because what they could have done is they could have said, look, we want you to write your applications. If you're going to do hard drive access, like the file system access, you're going to have to do that one way. But if you want to access information to and from a network card, well, that's going to be a completely different way. Oh, you want to access and have information to a database? Well, that's going to be another way. You know what? Sun didn't do that. What they did was they abstracted everything from the source and the destination of your data. And what they did was they created streams to allow me to do that. Here's the idea. First of all, what is a stream exactly? A stream is binary information. That's why you see 1, 0, 0, 1, 1, etc. that flows in and out of your application. And input, an input stream, is anything that comes in from some external source. Now, again, because we've abstracted it, because Sun abstracted it, it's a stream when it comes in from a database server, or standard input like the keyboard, or a file system, or an email server, or a web server. It doesn't matter what the input really is, what that stream is, because it all becomes this type of a stream. Once you have data input into your application, you could choose to modify that data, edit it, do whatever you need to do, and then you could output it via an output stream. So we have two basic types of streams: input streams and output streams. Notice how we could take information in from a database via the input stream, and then we could output it to whatever we want. We could maybe write it to standard output. Standard output is the DOS console, the black console, DOS looking thing that we've been using for a while. Maybe I want to output it to a database server. Maybe I want to take data in the form of an input stream and save that information as a text file. You see, it doesn't matter. Because everything is kind of based or bottom line to a stream, it's abstracted, meaning that streams in Java I/O are really independent of the underlying source of the stream and destination of your data. As I said earlier, there are two main classes, base classes, that everything stems from. Information coming into your application is going to be in the format of an input stream. Information coming out from your application to some kind of destination is an output stream. So the input stream is really the base class for all byte stream input. Byte meaning binary. Now we have character data and raw binary data, and I'm going to get a little bit more into that later. The base class used for byte stream output would be the output stream. Now notice how I'm saying the base class, because the base class is the ultimate parent class for Java I/O. It'll either be some kind of an input or an output stream. Now the namespace, or the package rather, that all of the output and input streams are found in, the main package, is the java.io package. So let's go ahead and take a look at that. Down here I've already got my bookmark to the Java documentation. And let me scroll down and find the java.io package, which is right here, java.io. So let's go into that. And we can see we've got a couple of interfaces. We've got data input, serializable. This will be a good one we'll talk about here eventually. Let's scroll down, and what I want you to do is let me just line this up here, and I want you to notice something. Let me slide this over. And you're going to start to see a pattern emerge. Because as I said earlier, the input stream class and the output stream class are the most fundamental classes that every stream class is based off of. So let me go ahead and find the input stream class here, and let's see what's going on in there. Here we have java.io input stream, and here it's directly from java.lang.object. So you could see it's right high. I mean, it's as high as you can get, right? I mean, it's a direct. It just directly extends object, which, remember, object is the root of all objects in the Java language. It's an abstract class. Okay, it's an abstract class is the superclass. Superclass, these are words that we talk about when we come into inheritance. If you remember, abstract classes cannot be instantiated directly. They are used solely to be inherited. Okay, so it's an abstract class, and it is the superclass, meaning it's the parent of all classes regarding input streams of bytes of information. Okay. Let's scroll down here and see what we have. We've got a very important method called the close method. And I'm going to show you later on how every time we're done with some kind of a stream, we should override and implement this close method. We've got various read methods that we're going to use. Okay, those have been overridden. And basically, that's it. It's a fairly simple class because it is the base for all the other classes. Now, one thing that is interesting, let's go into, let's say, the read method here. It's an abstract class, an abstract method, which means we need to go ahead and implement it. But look at this. It throws the I/O exception. That means that we have two things we're going to do whenever we're going to utilize a method like read. And that is that we have to encapsulate it or encase it in a try-catch block, or our method that's using it simply has to throw I/O exception, and hopefully it gets bubbled up to the top. Okay, so that's the input stream. Now let's take a look at the output stream. So let me come over here, and here I'll click the output stream. And as you expect, output stream is the base class for all output. Okay, so it's fairly simple class. It's right underneath object, so it's underneath it. And here, by the way, I could have shown you that too on the input stream, but here you could see direct classes. We've got byte array output stream, file output stream, file output, filter output stream, etc. And I'm going to talk about some of those. Output stream itself is an abstract class, very similar to the input stream. Okay, and we have the close method. Okay, so we want to close our output streams. But notice here, when we are dealing with output, we are writing output. We read information into our application. That's why when we were talking about the input stream, we saw read methods, but now we're talking about the output stream. So we're going to see several write methods. Okay, various write methods. Okay, so let me kind of show you what's going on over here, because depending on what you're reading, you'll have some kind of an input stream or an output stream, and you're going to see a pattern emerge, like buffered input stream, buffered output stream. We're going to use that here shortly. Data input stream, data output stream. Byte array input stream, byte array output stream. You can see there's usually a corresponding input stream and an output stream. Piped input stream, piped output stream. Print writer, print reader. Talk a little bit more about those. What else do we have in here that is kind of like it? For the most part, I think I showed you the most of them here. Here we have the filter input stream, filter output stream. Okay. We have a file input stream, file output stream. So you start to see this pattern emerge. Not only will you see a pattern emerge with the input and output streams, but you'll also see that pattern emerge with readers. Okay, so what I'd like to do now is write a fairly simple console level application. All right, let's take a look at an application that I wrote. It's just a basic little class, and it's a basic class called Basic IO, appropriately named, or aptly named, I should say. Now, of course, what I did up at the top is I imported the appropriate package. And all of, if not most of, the over 50 classes that Java has for us to do I/O are found in the java.io package. So you always want to do that. Now here's my main method. Now here's my try-catch block, because I told you earlier that the various read methods go ahead and throw I/O exception. So let's see what I'm doing. Let me just kind of give you the end of the story real quick. All of the applications we've written so far that are command prompt or console application have been using output streams. We just didn't realize it. I didn't tell you that yet. Now, here I am using an input stream reader. Let's take a look and see what the input stream reader allows me to do. So let me return to the documentation, because the input stream reader is very nice little class, and it introduces me and introduces you to the reader classes and the writer classes. Now here we can see that the input stream reader directs from java.io reader. To make I/O easier in Java, Sun implemented readers and writers, which do some conversion things for me. Here we can see that an input stream reader is a bridge from byte stream to character streams. The application that we're getting to write takes information in from the keyboard, okay? Now, information coming in from the keyboard is not just merely simple text. It's byte streams, okay? It's binary streams. But it's text characters. I mean, I want them to be text characters, right? I mean, I'm just typing letters. So I want it to be character streams. Well, any of these reader classes, like input stream reader, you know what it does? It converts that for me right on the fly. So I don't have to worry about that at all, okay, at all. And here we can see that the input stream reader, here is the constructor. It can take a couple of different parameters to instantiate it, but the first one that we see here is that it takes an input stream as a parameter. So let me go ahead and show you what I did in mine. I passed system.in. Now we've seen system.out for a long time, but let's go ahead and take a look at what system.in is. So let me go to java.lang, click on that link there, and I'll scroll down to system. Let's go into there. And here I'm in java.lang.system. It's a final class, which means you cannot go ahead and extend more from it, okay? You cannot extend it. Abstract classes are meant to be inherited from. Final classes are blocked, not inherited. They're sealed, which is the terminology used in C#. Okay, look at this. System.err, system.in, system.out. They're static, right? So I'm not going to instantiate an instance of the system class. I can simply say system.in. And if you take a look at what system.in gives me, it's of data type input stream reader. Input stream reader. Well, you're probably already looking at the notes here on the API and the documentation, and you're seeing that system.out is a print stream. Okay, so let me just hold you off on that. So system.in is itself in the format of an input stream reader, an input stream rather. And system.in represents standard input, if you will, which is basically the keyboard. So I instantiate a new input stream reader, which takes as an argument here, what I'm passing it is basically the keyboard, and the input stream reader class is converting that byte data type into character data type, and I simply called it ISR. Now here's the thing. Stream readers and stream writers look at small chunks of data, but that's a little bit, that's too much processing. So what we like to do is buffer it up and look at larger chunks of data. So we pass our input stream to a buffered reader, which I simply called standard input. Okay, now I can buffer that data and read it in larger chunks. I'm using an output stream, an output writer, to go ahead and write, please enter your name. Notice how I'm not using print line. You'll see the effect of that here in a little bit. I'm using the input stream reader's readline method to take information in from the command prompt and store it in a string called input data. And then I'm simply going to say welcome and pass that back to you. So let me go ahead and compile this, and we'll run it, and let's see what we get. Notice how it's saying, please enter your name, and I've got a blinking cursor here. Well, it's saying, please enter your name and giving me the blinking cursor because I am using system.out.print, please enter your name. So print just prints directly to standard output and does not put a line after it like the print line method does. So I could go ahead and type Robert. So I'll type R-O-B-E-R-T, bar. And now when I hit enter, let's see what's happening here. Let me put this down. And when I type in my name and hit enter, I'm calling the readline method of my standard input, which is an instance of the buffered reader. So it's going to buffer that data, store it into the string, and then it's going to use a print writer to go ahead and print that information back out to the standard output. The standard output is the console. Now what I want to do is go back to the documentation and investigate with you this system.out. System.out is of data type print stream. So let's take a look at what a print stream is. Take a look at this family history. Our print stream class inherits or is a filter output stream, which is itself as an output stream, and there is the connection. There's your shine. There is the connection. So that is how we can use the system.out, which is itself a type of print stream, but a print stream is a special type of output stream generating output that we can go ahead and use to write to standard output, in this case, the DOS console. Let's take a look at what we have here. You can see we've been using, let me go back to my application, we've been using this for a long time, system.out.println, system.out.print. Well, where is that coming from? How do I know about those methods? Well, take a look. I can print a Boolean. I've got system.out.print a character, system.out.print a character of an array of characters, a double, a float, an integer, all sorts of stuff here. Here's println, and the println method, you know, has all various forms and shapes that takes different types of data types as well. Let's go ahead and return back to the example, because what I want to do is give you kind of 5 steps for creating console-based user input. And these 5 steps will help you along the way because you'll be able to do more advanced input. The first thing you're going to do is you're going to use the system.in, which gives you that input stream, okay, to create an input stream reader object. And that's what I'm doing here. So I'm using system.in to create an input stream reader. Then what I'm going to do is I'm going to utilize the input stream reader, and I'm going to pass it to a buffered reader object. This allows me to buffer my information so I can read it in larger chunks. Then what I did here was I used the output stream, and I used a print writer to go ahead and write to the command prompt, basically prompting my user for, you know, entering some information. Then I use a buffered reader to go ahead and read it. So here's the buffered reader standard input, and I'm using the readline method to capture that data and store it in a string. Then I can do something, you know, you could utilize that information. Here I'm simply utilizing that information to go ahead and print it back to you. So 1, create the input stream reader. 2, create the buffered reader. 3, go ahead and prompt your user. 4, get the data, collect the data using the read line or some kind of read method. And 5, go ahead and do something fun with that data. Notice how all of this occurred in the try-catch block because readline throws the IO exception. How do I know that? Let me show you one last time here. Let's go back to the documentation. I'm going to go back into java.lang, and let's go to that buffered reader class. All right, and let me scroll down here and let's see the methods that we have. And we're looking for any of kind of the read methods. Okay. Here's readline, okay. returns a string. Let's go into it. And it throws IO exception. So I'm not just, making that up. This application will not compile if I'm not catching with IO exception. Now what I want to do is show you a nice advanced example, kind of building on what we talked a little bit about earlier with swing. What I did here was I created a swing application. And I'm not going to go into too much of the details about the exact nature of the swing part because we've talked about it. But essentially I went ahead and created a JFrame called my notepad, and on the JFrame I built a nice little GUI with some buttons and whatnot. Let me go ahead and run this and show you what it does. So I'm just going to run it from within TextPad, and basically it brings up a window. Let me kind of shrink it down so we can get a little bit of a better view of it here. It brings up a window, and by the way, I'm writing debug code, if you will, in the back of it so we could see what's happening. And it's a very, very fundamental text editor. So I'm going to write some stuff in there. I'm going to write my favorite time of year is winter. I love the snow. I love the snow. Too bad I don't live in a climate where it snows. I don't know, just some kind of goofy deal. I do miss the snow. All right, I'm going to save that. When I hit save, what's going to pop up here is a built-in Java dialog box. I did not write all the code for this. This comes right out of the box with Java. All this functionality to look at the files in a more detailed view, to click home if I want, to go to my desktop. I could drop. All of this is basically built right into Java. Okay, so I'm just kind of taking advantage of it. I could go ahead and double click on that. I can rename it, all sorts of things. So let's go into my Java and my Java directory. And I'm going to right click on it, and actually I'm just going to hit enter on it and go into there. So go into that. Now that I've opened the Java directory, let's go into the IO directory. So I'll click open there. And I'll call this file snow.txt. And I'm going to save the file. So I'm going to click save. Now, I had a code up what to do when I click save. By the way, notice here on the back, it's telling me it's save the file snow. I don't have to do that, but I just chose to do that. So I'm going to quit, and I'm going to close that. Now I'm going to go ahead and rerun it. And this time what I'm going to do is I'm going to open the file. So the application will come up. Here we go. I'm going to say File, Open, and the dialog box to do that pops up. And I can navigate to snow.txt and click Open. So I created a file, and I saved the file. All right, let's take a look at the Java code necessary to implement the I/O portion of that. Now what I did was I'm going to kind of work from the bottom down a little bit, from the bottom up I should say. Here I've got a couple of menu items with action listeners, and this is event handling. We talked about this before. Let's go ahead and talk about what's happening when I click the menu item file save.addActionListener. What it's going to do is it's going to create a JFileChooser. A JFileChooser is what allows me to open up and save files. Okay, it's built right in. It's baked into the Java API. I don't have to code any of that stuff up. And what I'm doing basically is I'm going to determine what is the save dialog. So I create a JFileChooser, and then I call, and I'm determining if it's a save file chooser, okay? Basically, I'm going to show that dialog. Now, here's where the I/O stuff is. Here's where all of that goes. Remember, this is the save, okay? So what I'm going to do is I use the JFileChooser, and I call getSelectedFile. Now, what that does is it returns a file, and this is where we begin I/O. So let's jump into the API, And let's go down, and right here in java.io, I've kind of got it queued up here, is the file class. Here we can see that we've got java.io.file, and here it's directly from object, and it's an abstract representation of a file and directory path names. So it basically gives me the directory and path name there. Okay, now what I can do is now that I've got a file called save file, I can output the file, basically save file, which is my file, .get name. What does get name do? Well, let's jump back into the API. Remember, my goal is to make sure you're very comfortable with the API. Nothing I do is magic. It all comes from somewhere. And I want to show you where that comes from so you can go ahead and do this too. So I think I kind of scrolled past it fairly quickly. Here's get name. It returns the name of the file or directory denoted by the abstract path name. So basically we're getting the path name here. All right, now what we're doing, and that's where you saw it written to the background there in the command prompt. But here's where the real I/O comes from. I create a new file writer. Create a new file writer. Let's go back into the API and see what a file writer is all about. So let me scroll down here a little bit. And I'm going to go into my file writer. Now you're starting to see the output stream stuff, okay? And a file writer inherits from output stream writer, inherits from writer. And to instantiate an instance of a file writer, we've got a couple of constructors, and you can pass to it an instance of a file. And basically it constructs a file writer object given the particular file object. So basically what I've done here is I've passed this file object into the file writer, and it knows the name of the file, and I'm calling that file output. Now the text area is called TA notes, and if I call the getText method, it returns to me the information, the text. And here's what I do is I call my file output write method, my file writer write method, and I'm writing to that output stream, all that text. Earlier I talked to you about the close method. Here I call the close method once I've streamed all that information out of the text box, out of the text area called notes, streamed it down into this file object, then I close it. Then what I do is I have TF, which is my text field file name, and I set that text, okay? So it's fairly straightforward. So once again, what do? I get a file object. I call the file object, and I create one by calling the JFileChooser's getSelectedFile method. It returns to me a file. Okay. Then I could pass that file into the file writer constructor, and it gives to me a file writer, which I call file output. Then basically I have a stream. See, file writers. Let's go back to the API. I want to be very clear what a file writer is. Let me scroll up. A file writer is an output stream. Okay, it's an output stream writer, which means it's anytime I have reader or writer at the end of it, it's handling binary to text or byte to character data conversion for me. So it's writing to that stream. Remember, here's a good rule of thumb. Whenever I am outputting information, I am writing it, and all the methods will be of the various write. Whenever I'm inputting information, I am reading it, and I will use readers, which you'll see here in a second. Once I'm done writing, I close it. Once I'm done writing, I close it. All right, now let's go ahead and take a look at how we go ahead and open the file. So let's scroll up here, and now I've got my file menu open. Okay, I create a JFileChooser, which I call JFileChooser open, and I'm basically looking at what I'm doing, and I'm basically determining whether or not I'm going to call the open method. And here I am calling the show open dialog, which allows me to go ahead and display the JFileChooser as an open dialog box, basically to open up a file. Now, once again, I still need a file object, and I call my JFileChooser's open method, just like I did previously. Okay, get selected file. Let's go down here. Here you could see I called get selected file too. right? So that hasn't changed, and it gives me a file. But now things get a little bit different because now I'm looking to read the contents of that file. So I use a file reader. Now the file reader does something interesting. And what I wanted to do is I wanted to get its length. So I called the open file, okay, I called my open file and I got the length method of it, which returns to me a length, and I went ahead and I converted it back to an integer and created a character string of that data, and I called it read buffer. Then what I can do is I can use my file reader's read method to read the characters in that character array. Then what I did was I called, and now I got the data, by the way. Now I got it. So what I do is to set the text of my text area, I pass the contents of the read buffer, and I instantiate a new string, and I go ahead and display it to you. Then, true to form, I close the reader, and then I'm done. And that's where the I/O happens. Notice I am catching I/O exception in both instances. I/O exception, I/O exception. So that's a fairly advanced example, but I just want to show you what the options are using input and output streams in Java I/O. In Java I/O, we talked about how we can use Java to utilize input and output in and out of our applications. Take data in, spit data out. Critical to understanding Java I/O is understanding the concept of streams. Streams are byte data, okay, coming in to our applications or that we're spitting out. Now, those byte data can be in the form of binary, which means, you know, kind of compiled computer mumbo jumbo, or it can be just character data, like ASCII text. And there are reader and writer classes that convert that stuff for me on the fly. As far as the classes go, the input stream and output stream classes are the parent classes for most of your I/O. Then we did a little bit of the fundamentals of input and output utilizing a console application. And then finally, I wrapped up by showing you some application of this using a Notepad application. I hope you have found this informative, and I'd like to thank you for viewing.